Alright, there's two what are called special right triangles that would be really helpful for you to memorize how they work. And if you can do that, then you'll find a lot of math problems as you continue your math career will become very clear. And these are special right triangles, triangles whose sides form nice and easy ratios, and um, so they're easy to remember, easy to deal with in math, and so we like them. We call them special. So there's two of them here that I want to talk to you about: the 45, 45, 90 triangle and the 30, 60, 90. And we just call them that because that's what their angles are. So 45, 45, 90 triangles have two angles that are 45 degrees each, and then their 90-degree angle. So the 45, 45, 90 triangle will be uh, equilateral. So these two sides are the same length, and um, in this simple model here, we're calling this side length 1. So since they're of equal length, then this would also be 1. And then by virtue of the Pythagorean theorem, we say that 1 squared plus 1 squared, a squared plus b squared, is equal to the hypotenuse squared. So 1 squared is 1, 1 squared is 1, 1 plus 1 is 2, 2 is equal to c squared, so c would be the square root of 2. So every 45, 45, 90 triangle will follow this pattern. Now the side lengths might not be exactly 1, 1 and square root of 2, but it'll be proportional to 1, 1 and square root of 2. So say, like I have this triangle here, and I know it's a 45, 45, 90. Well, let's say this side length is 2, not 1. Well, if this is 2, that means I'm multiplying this side by 2. I'm multiplying everything by 2. I'm proportional by a factor of 2. So then this side is also 2, and these two shorter sides are the same length. And then the hypotenuse is 2 times the square root of 2. So it follows that same pattern. It's proportional. So I could say the ratio of 2 to 1 is equal to the ratio of 2 to 1. Just checking corresponding sides here. Is equal to the ratio of 2 square root of 2 to the square root of 2. I'm writing over Mathceratops' head. Sorry, man. So yeah, these are all equal to 2, which I know. I mean, I blew this up by a factor of 2, so that's the proportionality there. So they all work that way. So they follow that easy pattern, which is why we like to use these 45, 45, 90 triangles. Another one is the 30, 60, 90, which is a triangle that has a 30-degree angle, a 60-degree angle, and a 90-degree angle. And the sides here follow the pattern of this one is 1, the hypotenuse is 2, and then the second longest side is the square root of 3. And the way you can remember that is the sides of triangles are correspond. So 30 degrees is the smallest angle of this triangle. So it's going to shoot across to the smallest side. So 1 is the smallest side. Okay, square root of 3 is between 1 and 2. The square root of 1 is 1. The square of 1 is 1. The square of 2 is 4. The square root of 3 is going to be between um, between 1 and 2 then. So this is the second smallest quantity, or second smallest side length. So 60 degrees is the second smallest angle. So it's going to shoot across to the second smallest side length. And then 2 is the largest side length, and the largest angle is going to shoot across to that. I don't know if that helps you remember. You can also think, here's the 90-degree angle. The shortest side is going to be 1, and then I'll just go 1, 2, like 1, 2, 3, but then make sure this is the square root of 3. So every 30, 60, 90 triangle is going to follow this pattern. And so again, maybe this triangle is 3 times as big as that triangle. So this side length would be 3, Um, the side length would be 3 times the square root of 3. And the side length would be 3 times 2, which is 6.